Alright folks, we're going to do some review of Fraunhofer's factoring, or the box method today, and then learn a couple new things. Okay, so I'm not going to go over every single example here. We're going to focus on some review of regular factoring, factoring to solve equations, and then see how it applies to some word problems on the back. So first problem here, there's not a GCF. Remember, we always look for that first because there's no number in common with all three, and I don't see a variable that shows up in all three. So what makes this a box problem is that number in front exists and it's not a perfect square. So setting up my box, I'm going to write, remember, my first term and my last term in the first diagonal. Multiplying those together, I'm looking for the factors of 28 that add to be 29. Now, since this number is bigger, okay, we hopefully can recognize that this is the 1 times 28. So I'm going to put 28x here and 1x here. So for this first one, GCF of that first row is 7x. And then I can kind of work my way around the box using that GCF, or I can use the factoring or the multiplication patterns that I see. So 7x times x gets me to 7x squared. 7x times 4 gets me to 28x. Similarly, x times 1 gets me to 1x, and 4 times 1 gets me to 4. So my factored form of this is 7x plus 1 times x plus 4. Okay. Next one over here. First thing we're looking for is a GCF. Again, this time we know there's a GCF because all those numbers end in 0. That means we can take a 10 out. When we do, we've got a 3m squared minus 8m minus 3 left over. Now, again, because this 3 is here, just like that 7 was there, this is going to be a box method because that exists and is not a perfect square. So setting it up here, I've got 3m squared, negative 3 here. I'm going to multiply those two numbers to get negative 3. And I'm looking for the factors of, negative 9. Looking for the factors of negative 9 that add to be negative 8. Okay. So the only factors of 9 are 1 and 9, or 3 and 3. In this case, we want to get to 8, so the 1 and 9 are going to do it for us. And because this is a negative 8, I need a negative there. So this here, negative 9m, and this over here, 1m. Again, you can flip those around. It does not matter. It just means what I have on this side, you would have on the top if you did switch them. Okay. First row, looks like there's a 3m I can take out. 3m times n gets me to 3m squared. 3m times negative 3 gets me there. And then m times 1 gets me to 1m. Regrouping, I've got the 10 out front still, then 3m plus 1, and m minus 3. Remember, checking these is a good idea. 3m times m should get me to this first term, and then the last term times the last term should get me here, with that 10 still coming along for the ride. Alright, we're going to skip 3 and 4 and move on to 5 and 6, making sure we can do the same type of process when there's an equal sign involved. So for this one, you have one edit step. We want to make sure it's equal 0 first before we go moving through our factoring flowchart. So this number 5 is set up for us, no problem. Okay, so we are going to look for a GCF. 8 to negative 3, nothing there. And because this 8 is not a perfect square, we're setting up a box. Okay, we've got 8x squared here, negative 3, which means I'm looking for the factors of negative 24 that add to be 2. So 1 times 24, I'll actually list them out for this one, just so we can remember, if you're stuck on them, this is the method. You want to list them all. And if you don't know the factors, either you're not great with your multiplication tables or maybe this number is really big, list them out and go backwards with division. So if you don't know 2 times what gets you 24, take 24 divided by 2 and that's the number you write. Similarly with 3, that's going to be 3 and 8, and then 4 and 6. 5 doesn't go in evenly, then I'm back up at 6, so that's all of them. I'm looking for 2 to show up. So these ones are 2 away from each other. That's good news for us because this negative means we need opposite signs. One positive, one negative. And if I need a positive 2, that means the negative has to go with the 4. So we've got 6x and negative 4x here. And then I'm going to do a GCF of that first row. 4x can come out. And then I'm filling in the rest of the box, either using GCF again, like the second row, there's a 3 that can come out, or by using my multiplication patterns. 4x times 2x gets me to that 8x squared. 4x times a negative 1 gets me to negative 4. Regrouping, I have 4x plus 3 and 2x minus 1. Again, just doing a quick check, 4x times 2x gets me there, and 3 times negative 1 gets me negative 3. We're golden. Okay. For equations, we want to think about each piece being equal to 0 and solving. Okay, so these ones are usually going to require 2 steps, and for this, we're going to subtract or add first, and then we'll divide after. So we talked about the shortcut for this being the opposite of what you see over the number in front. So for this one, that comes from the first step I would need to do is add the 1. Okay? And then the second step would be divide by 2. So there's my positive 1/2. Okay? If it helps you to write out the math and see those equations, you are more than welcome to do that. Okay. I'm going to have you pause the video and try number 6. I'm going to give you a hint here. There is a GCF, so do not set up your box until after you take out your GCF. Okay. Pause the video and try that one. Okay. Hopefully you found that it was 3, which leaves 3n squared minus 2n and then minus 5 equals 0. So then your box would use the 3n squared and the minus 5. So I'm looking at the factors of negative 15 that add to be negative 2, which looks like a negative 5 and a positive 3. With that, I can write 3n and negative 5n and GCF by way around. So you should have come up with a 3 in front. Make sure you drag that down, just like with the equal 0. And then 3n minus 5 and n plus 1. Remembering that these two pieces, those binomials, can be flipped around. That's okay. We just want to make sure the negative is with the 5 and the positive is with the 1, because I have to get to that negative 5, and those negatives being in the right place are what help me get to that middle term. Okay, with this now, I can solve my equation. The first piece says 3 equals 0, so that doesn't work. The second piece gives positive 5, adding it over, divide by 3, 5/3. And then the second piece, I just had one step, subtract the 1. Okay. Now we're going to go ahead and go to the back side, get to see the stuff that's new. Okay, so we're going to talk about Newton's law. And Newton's law, although science, is really applicable to what we've been learning about, because all of these things we've been factoring, they have got these squared terms that are showing up for us. And those squared terms are, remember how we know we're not done? Because factoring is one method we can use to solve these quadratics, okay? So, one really important application of quadratic equations are Newton's law, which talks about projectile motion. Okay, so that's motion of an object that has some initial height, okay, and that's this h0, which is pronounced h0, okay, some initial velocity force, that's our v, and then this last piece, the negative 16, is already put in there for us. That relates to the acceleration due to gravity on Earth when we're talking about feet and seconds. So, when we're dealing with a problem in general for Newton's law, I will a lot of times give you a graph so we can talk about the pieces that were given visually to help us answer the question. So hopefully you remember from graphs we've talked about this year, time usually goes here. So I'm going to have you put a t there. Instead of dealing with an x-axis, we're going to have a t-axis for time. And instead of having a y-axis, our other thing we're talking about is height. Okay, and these for us are always going to deal with seconds and feet. Okay, Newton's deals with seconds, that's universal, but there is another Newton's formula that uses the acceleration due to gravity in meters instead of feet. Okay, we're going to use feet because it's a nicer constant than the other one. Okay, so our goal is to see some numbers in here, interpret how it looks on a graph, write an equation to help us solve it. So suppose a cheetah pouncing on an antelope leaps with an initial upward velocity of 19 feet per second. How long is the cheetah in the air if it lands on the antelope's hindquarter 3 feet from the ground? Okay, so the first thing I want you to do is just rewrite this equation. H equals negative 16 t squared plus vt and then plus h naught. If we think of this in relation to what we knew about y equals mx plus b, we have a lot of letters here, just like we have a lot of letters here. But in an equation, some of those letters stand for variables that stay, and others are constants that we fill in. So for this equation, the constants that we have to fill in, okay, are here, and then the t gets to stay. This h is acting as our y, but in the case of solving equations, we're going to know that value. So going back to the problem, it said the initial upward velocity is 19, so they tell us v is 19. Then it says, how long is the cheetah in the air if it lands on the antelope's hindquarter 3 feet from the ground? So because this is where it lands, this is the end height. Okay, and the end height is 3 feet off the ground. So then the only thing we're missing is this start height. Okay, the start height is talking about where the cheetah started, and it's just pouncing, which means it starts on the ground. If they don't give you an initial value, then the default is 0. So the start height is 0. And that start height is our h naught. Okay, so I want you to write up here, this is our end height, and this one is our start height. They use that naught because when we talk about these things, it really relates to time 0, the start height, relating back to when we did linear equations, the y-intercept. Okay, so it goes when x is 0, or in this case t is 0. So that's where that 0 of the naught is coming from. Now that we have all the numbers we need, we're going to substitute them in, and then it becomes exactly like all the problems we've been practicing. So first up, our end height was 3, then negative 16 t squared, plus velocity was 19, then our t, plus our start height of 0. Hopefully you remember from solving equations, we need to make sure it's equal to 0 first. So I'm going to subtract that 3 over, which becomes 0 equals negative 16 t squared plus 19t, and then minus 3. Okay, we're going to do two things for these special types of Newton's law equations. We're going to move the equal 0 over the other side. Okay, so we can do that here. Just get rid of it. And then we're also going to look for a GCF. Okay, so with this, negative 16, 19, and negative 3, there's nothing in common with all three. But there's this negative that's showing up. And in fact, Newton's law has that negative 16 that's a constant, so it will always be there. So what we're going to do is really factor out a negative 1, But because these have lots of steps, instead of writing the GCF factored out like we normally would, I'm going to have you just divide it away. So divide by -1, but remember with division, what you do to one term, you have to do to all terms. So -16 over -1 is +16. And then this switches to a -19. And this switches to a +3. 0 divided by anything is 0, so that's why it's fair game. Okay? Now, in the case of no GCF, you can just switch all the signs. You don't necessarily need to write the divide by a -1. But in the case of there is a GCF, it's nice to take care of both of those steps in one process. Okay, so now that we have this, we have box factoring again. Okay, 16 is a perfect square, but 3 is not, which means we're going to have to go ahead and set up our box using that 16 and our 3. Okay, multiplying those together, we get 48, and we're looking at the factors of 48 that add to be a -19. I'm going to have you pause the video and find those factors, because that's where we need to get at the end of all of our lessons, is making sure we can find those factors, even if it takes a little while. Okay, so pause the video and try that. Okay, hopefully you got it actually was the 16 and 3 itself. Okay, -16, -3. So that means I can factor out a 16, a -3. This is just t, and this would be -1. Okay, so my factored form looks like 16t minus 3 times t minus 1 equals 0. All of this we were solving to answer this question. Okay, so here we're adding over the 3, dividing by 16. We're adding over the 1, and getting two different answers. Let's go ahead and add to our picture here to see what's going on. So we have this cheetah who's starting on the ground. Okay, so at 0 seconds have passed, we're on the ground. I'm going to start with that point. Then, we're relating height and time. So after some time has passed, when we talk about a cheetah leaping, it's going to go up as time passes, but it can't keep going up forever. It has to eventually come down. Okay, so the height is going to get higher and higher, but eventually it will come down. Now, this is going to actually happen in this like arc, but it's not the shape, I want to emphasize, it's not the shape of the cheetah leaping, because we're not measuring the distance here. It's the relationship between feet and seconds. And Newton was the one who determined that this would happen the same way each time because of gravity. Okay? Now, so we're starting there, but we're actually ending, remember, 3 feet from the ground. So I'm going to mark a place to be 3 over here and draw a little dash across it. So this is my landing point right here, where the cheetah hits the antelope, meaning this part of my curve doesn't exist. Okay? When we talk about quadratic equations, their graphs look like this U, either facing up or a U facing down. And we're going to talk more about their graphs in Chapter 10. Okay, so here we just have part of the U because we're relating time and feet. Well, we had two different answers here because there were two different times that related to this height of 3 feet that we originally set up to get our equation. It was 3 over 16 and 1. So, when I want to know how long is the cheetah in the air, I want to know how long or how many seconds did it take to get from my starting point over to my ending point. And that actually is the second answer, not the first one. So the cheetah was in the air for 1 second. Okay. We'll practice one more of those. This one says a person throws a ball upward from a 506-foot tall building. The ball's height in feet after t seconds is given by this equation. And the ball lands on a balcony that is 216 feet above the ground. How many seconds, again, was it in the air? So this is Newton's law again, with that first number being the constant, this being my initial velocity, and this being my initial height, which hopefully makes sense from this problem, my given starting point. So I'm going to go over my graph again. Here is my time in seconds. And here is my height in feet. Okay, and I was told that my starting height was 506. So some starting height of 506. I have a person throwing a ball, and it says upward, so it's going to go up, but gravity is going to cause it to come back down again, and eventually it's going to hit the ground unless something gets in its way. So here it says the ball lands on a balcony 218 feet above the ground. So here, 218 is going to be less than half of that, somewhere around here. Okay, so I'm going to start at this point, and then I am going to go ahead and draw my little arc that ends when I hit this imaginary line. Okay, so my start was 0, 506. Our job is to figure out, what's this number? How many seconds does that take? Because I know it's 218 feet off the ground at that point. So that is where we come in, solving for t. Good news is they gave us most of this equation. We just had to fill in this 218. That's our end height. So we're going to start with 218 equals negative 16t squared plus 48t plus 506. From here, remember the first step is to get my equation equal to 0. And just like the last time, we're going to just subtract over that constant, minus 218 on both sides. This side cancels out to 0. If you want to switch that over at this time, you're more than welcome to. I usually do it in the next step. Okay, 506 minus 218 is 288. And then at this point, we're looking for GCF. This time, they're all even, so at least a 2 goes in. But what I like to do is try the 16 first. And in this case, 16 does go into all three numbers. So remember, I want to get rid of the negative every single time here. So I'm going to divide by a negative 16 on all of these. Okay, this first one I'm calling 1 t squared, or just t squared. They cancel out. 48 over negative 16 is negative 3t. And then positive over negative, we've got 288 over negative 16 is a negative 18. And then now I'm going to put that as equal 0. The good news about this one is because of our big GCF, this becomes easy factoring. Okay, the only way to get to t squared is t times t for us. And then we're looking at the factors of negative 18 that add to be negative 3. So 1 and 18 doesn't work, 2 and 9, 3 and 6 does. So I need a negative to be with the 6 in order for my sum to be negative. So we've got a plus 3 and a minus 6. We've got two answers here, negative 3 and positive 6. And we only had one intersection on this problem. If I compare that to the other one, there were 2 places where it intersected. I had 2 answers, but only one of them worked out for the end. Similarly here, the bigger one's going to be my answer, but hopefully you know that this one isn't possible anyway, because we're talking about time, and time cannot be negative. I've said this word in this class before. This is considered an extraneous solution because it's a solution that doesn't check in context. Okay, so for this one, the ball was in the air. For 6 seconds. And that's it.